Hello everyone, my name is Pipin Abram and in today's video we'll be solving CBSE's latest sample question paper of term 1 for class 10th, and the subject is science, and in that science subject we'll be focusing on the physics part of the paper. So this is the solution for your sample question paper of term 1 2021-22 for class 10th science physics part. So for all those who are new to channel, please do like, share and subscribe the channel. And with that being said, let's get started. Okay, so this is the first question. So look at the first question. This is 17th question of the sample paper. Which of the following mirror is used by dentists to examine a small cavity in a patient's teeth? We have four options: convex mirror, plane mirror, concave mirror, or any spherical mirror. So obviously one thing is very clear, that it will not be a plane mirror, because plane mirror will give you the same size of the object. So plane mirror will not be our answer. So it will not be plane mirror, right? Okay, next, it will not be any spherical mirror, because you have to be specific here. You have two options: convex mirror and concave mirror. So we need to be specific here, right? Okay, now the option remain convex mirror or concave mirror. Now when we talk about concave mirror, then we know that in concave mirror there is a very specific case in which you see a real, we see a virtual and erect image, right? So for example, let's say this is the principal axis, and let's say this is my focal focus, and this is my center of curvature, right? So let's say if my object is placed between my pole and between your focus, then obviously the image will be something like this, right? And we know it will be something like this, and the image will be enlarged and it will be inside the mirror. So this is actually your virtual image, and it will be larger than the object. So this is your object, and this is your image. So basically you guys can see my object is enlarged, and if the object is enlarged, I can very nicely see the object with the help of this image. So basically and also in the case of your convex mirror, we do get virtual image, but the size of the image is either point like or very small, right? So I do not want a mirror which actually give me a small image of whatever object that I am focusing it on, right? So the answer to this question is concave mirror. And also we're talking about this specific case when your object is placed between your focus and the pole, right? So that's why you must have seen the dentist actually put it very close to the cavity so that the doctor can see the cavity, right? So the answer to this question is concave mirror, right? Okay, so let's move to the next question. The next question is, yes, question number 18. Which diagram shows image formation of an object on the screen by converging lens? So obviously first thing, your convex lens is what we call as a converging lens. So we have to find out of these four images which image is actually correctly showing the characteristic of a converging lens, right? So here let's talk about the first image. So in the first image, there is an object and the rays coming parallel to the object, they are converging to a common point. Normally it should converge at focus, but it is converging at twice of focal length, right? So I think this is not the correct answer. Let's go to the second one. So the second one also, we have the object here and the rays are coming parallel and they are converging at a point, but again this point is twice the focal length. So again this option is not the right answer. Okay, let's look at option number C, right? So in option number C, the object is here and the rays are coming parallel and it is converging at a common point. Yes, it is converging at a correct point, that is the focal length. So it is converging at focus, right? And obviously the second ray is coming very straight to the to the optical center, right? So yeah, I think this one is truly showing you the characteristic of a converging lens. Let's talk about D. So in the D, yes, it is converging at focus, but this is not the characteristic of a converging lens. So the answer is D, right? So answer is option number C. I hope that is understandable. Yes. Okay, let's move to the next question. Let's move to the next question. This is question number 19 of your sample paper. Which of the following can make a parallel beam of light when the light from a point source is incident on it? Okay, so which one of the following can make parallel beam of light when the light from a point source is incident on it? Okay, so basically you have different options here. So you have concave mirror, you have concave mirror as well as convex lens, then you have convex mirror as well as your concave lens, two plane mirrors placed at 90 to each other, and concave mirror as well as your concave lens. So let's one by one, let's see all the possible. Let's start with the plane mirror. So in plane mirror it is written that two plane mirrors are placed at 90 to each other. Okay, so let's say I have this one plane mirror, this is the next plane mirror, so this is the plane mirror here, right, and they are placed at an angle of 90 degree, right? So the question is, if let's say I have a source of light, right, so you have a point source of light, so obviously the light rays will be coming in all the possible direction. Is that a yes or no? Light rays will be coming in all the possible direction. So you guys can see the light rays will come and it will reflect in different direction, right? So it cannot make parallel, you know, beam of light. It cannot make parallel beam. So obviously option number C is wrong. Now let's look at option number B. Let's look at option number B. So option number B says convex mirror as well as concave lens. So convex mirror, when we look at convex mirror, so convex mirror is something like this. So this is your convex mirror, right? So this is the principal axis. So obviously whatever, let's say this is the object, so whatever the, you know, the parallel beam of light is coming, or let's say the point is coming, so it will simply, you know, it will simply reflect those images in all the possible direction, right? So it is actually a diverging lens, so this will not be the option again. So let's talk about okay, let's talk about concave lens here. Concave lens is this lens, right? This is your concave lens. So for concave lens also, concave lens is again a diverging mirror. So obviously let's say your images are coming from a point. So if the images are coming from a point, what it will do, it will diverge them. It will diverge them. So obviously it will not make them parallel. So this option is also wrong. So your concave lens is wrong, your convex mirror is wrong. So again here is you have concave lens, so this is also wrong. Let's talk about concave mirror. So you have this option number A, in which you have concave mirror as well as convex lens. So let's talk about that. So you have concave mirror as well as convex lens. So let's talk about concave mirror first. So let's say I have this concave mirror. So I have this concave mirror. So this is my concave mirror, right? Okay, so let's say this is the principal axis, right? So we know if the rays are coming parallel to the principal axis, if the rays are coming parallel to the principal axis, and let's say this is my focus, this is my center of curvature. So if the rays are coming parallel, then they converge at the focus of the mirror. Yes or no? So no matter how many rays come, right, they are going to be focused. They are going to be, you know, converging at your focus. Is that a yes or no? So basically I can reverse it. I can actually reverse it, and I can keep my light source at the focus. So at the focus, all of the light rays, you know, all of the light rays which are going, right, it is actually making my rays parallel. Is that a yes or no? So this is actually fitting my description. Okay, let's look at the convex lens now. Let's look at convex lens now. So already you know the answer, but still to confirm the answer, let's look at convex lens. So you have this convex lens, right? So you have this convex lens. Now let's say this is your first focus, this is your second focus, right? Twice of first focus, this is your second focus, and twice of your second focus. So obviously I know if I have a point source at f1, then what is going to happen? The rays that are going from your f1 after reflection will be parallel to my principal axis. Is that a yes or no? That is also a possibility. So we can actually find it like that also. So basically your point, your point source is making the rays parallel, right? So this is actually fitting my description. The answer to this question is concave mirror as well as convex lens. I hope that is understandable. Okay, great. So if that is understandable, let's move forward to question number 20. This is question number 20 of your sample paper. Consider these indices of refraction. For glass it is given 1.52, for air it is given 1.0003, for water it is given 1.333. Based on the refractive indices of three materials, arrange the speed of light through them in decreasing order. All right, okay, so one thing you have to be very careful here. These are your refractive indexes, right? Of it is given for glass, it is given for air, it is given for water. Now one thing you have to be very careful, that your refractive index is inversely proportional to the speed of light in that particular medium, right? So if your refractive index is more, the speed of light will be less, right? If your refractive index is less, then the speed of light will be inside that medium will be more, right? So this thing you have to keep in your mind. And then what I have to do, arrange the speed of light through them in decreasing order. So I have to arrange them in decreasing order. So speed of light in air will be actually greater as compared to speed of light in water as compared to the speed of light in glass, right? Because in air, you guys can see, for air the refractive index is the lowest, 1.0003. For water, refractive index is 1.333, and for glass, refractive index is coming out to 1.52, right? So let's say this is there in any of the options. So you guys can see the speed of light in water is greater. No, this is wrong option. Speed of light in glass is greater than the speed of light in water. No, this is again wrong. Let's talk about C. Speed of light in air is greater. Okay. Speed of light in water. Okay, great. Speed of light in glass, right? Okay, so option number C is the correct answer, right? Option number D is also wrong. So I hope you guys can understand that. Yes. Okay, let's move forward. This is question number 21 of your NCERT. If a beam of red light and a beam of violet light are incident at the same angle on the inclined surface of a prism from air medium and produce angles of refraction R and B respectively, which of the following is correct? R is equals to V, R is greater than V, R is equals to 1 upon V, or R is less than V. Okay, so basically we have a prism. So let me just very quickly make a prism. So this is a prism. Okay, so I have a prism. So a beam of red light and the beam of violet light, right? So beam of red light and beam of violet light are incident at the same angle, right? So basically we remember that your white light is made up of Vibgyor, right? So for if I talk about Vibgyor, so I know inside the prism violet light bends the maximum, right? Violet line bends the maximum. This is something which we know. And red bends minimum, right? Red bends minimum and the violet line bends maximum, right? So if that is true, you're supposed to find out, let's say this is R is the angle of refraction for your red light and V is the angle of refraction for your violet light. You are supposed to find out which of the following options is correct, right? So let's say this is my red light, right? So red light I incident on one end of the prism. The next step is I will simply make the normal, right? So let's say normal will be perpendicular here. So I have made the normal. So let's say this angle is some angle of incidence, right? So obviously I know it will refract, but it will refract very less, right? So let's say it has reflected. So this is your R, right? I hope you guys can understand that. Okay, great. Now let's say at the same path I am I'm bringing my violet light, right? So at the same path I'm bringing my violet light, right? So if obviously the angle of incidence is same, right, but it will bend towards normal more. It will bend towards normal more, and this will be my angle of refraction, right? That is your angle of V. So by making the diagram, I can actually see very nicely that your angle R is greater than your angle V. Is that a yes or no? Can you guys see that? Yes, your angle R is actually greater than your angle V, right? So let's see if that is there in the option. Yes, it is there. Option number B is the correct answer, right? Okay. Okay, I hope that's understandable. Shall we move forward? Okay, let's move forward. Yes, this is question number 22 of your sample question paper. So question number 22. So you have this diagram here. So examine the above figure and state which of the following option is correct. Okay, great. One small box in the figure is equal to 1 centimeter. So that means this one small box is actually equal to 1 centimeter. You have to remember that. Okay, good. So you have four options here. The mirror has a focal length of -6 centimeter. Is it? Okay, let's see. So this is your focus. So you guys can see according to question, one box has, so one small box figure is equal to 1 centimeter. So that means this is 1 centimeter, this is 2 centimeter, this is 3. So basically it is actually 3 centimeter. Focal length is actually, you guys can see focal length is actually 3 centimeter. But you have to understand the focal length will be negative. Why it is negative? Because we know according to our sign convention, all of our measurements are from the pole, right? So from the pole, if you want to measure the focal length, you have to go in the left hand, in the left direction, right? So whenever we go in the left direction, according to our sign convention, it is taken to be negative. So this is actually -3 centimeter, right? So if your focal length is -3 centimeter, then automatically option A, which is telling you 6 centimeter, and option D, which is also telling you 6 centimeter, is automatically wrong. So we will not look at option number A and option number D. Let's look at option number B and option number C, because option number B and C are telling me 3 centimeter and -3 centimeter and -3 centimeter. Okay, will produce an image of magnification -1 or will produce an image of magnification +1. Now let's complete this image, right? So this is the ray and this is, okay, and then this is the ray, right, and this is, okay, something like this, and you guys can see my image is exactly at the same point. So basically magnification will be 1, you guys can see, because the same size of the image is there. But you have to understand magnification is given as height of your image upon height of your object, right? Now how height of your image is actually in the downward direction, that is it should be negative, and height of the object is in the upward direction, that is positive, right? So overall I can say magnification will come out to be negative, right? So -1 will be the answer. So that means option number B is the correct answer. I hope that is understandable. Yes. Okay, let's move forward. Okay, this is question number 23 of your sample paper. So you have the diagram here, right? So the angle of incidence from air to glass at point O on the hemispherical glass slab is. So you have this hemispherical glass slab and you're supposed to find out the angle of incidence from air to glass at point O. So this is point O. From air to glass we are actually going. So you are supposed to find out the angle of incidence. So you guys can see this is not feeling any kind of bending, right? Can you guys see that? Although we are changing from air to glass, right? Air to glass, we are changing the medium. So normally in normal cases, if you are changing the medium, there must be some bending, but you guys can see there is no bending here. If there is no, you guys can see this is the radius of your semicircle. That means it should be perpendicular. It should be the perpendicular. So you guys can see your incident ray is perpendicular. That means your incident ray is coinciding with the normal, right? Your incident ray is coinciding with the normal. That means the angle of incidence will be equal to, yes, the angle of incidence will be equal to 0. Yes or no? The angle of incidence will be equal to 0. I hope that is understandable. Yes? Okay, let's move to the next question. This is question number 24 of your sample question paper. So a prism ABC, this, okay, you have this prism ABC with BC as base. Okay, so BC is the base, is placed in different orientations. A narrow beam of white light is incident on the prism as shown in the following figure. In which of the following diagrams after dispersion, the third color from the top of the spectrum correspond to the color of the sky? Okay, so one thing you have to be very careful, that your BC is the base. So if BC is the base, then BC will not be the reflecting side. The reflecting side will be AB and AC, right? So refracting side will not be BC. So here also reflecting side will not be BC. Here also refracting side will not be BC. Here you guys can see the ray is actually passing through your BC. So basically this option automatically cancels out, right? Now let's look at this option. Okay, in this one, your AC, your incident light is coming from AC, and here you have your, BC as your reflecting. It is making it to be a reflecting side. So again, this option, is also not right. So we are left with option number 1 and option number 2, right? Okay, now let's try to actually draw this. So obviously first you will have a normal here, right? Okay, and we know the red color will deviate less, and on the other hand your violet color will be deviate more, and you will, and when it comes out, you will have a band, right? So here you will be having, I can write it here, you will be having Vibgyor, VIBGYOR, and the red being at the top. Is that a yes or no? So according to the question, in your first option, the third color from the top of the spectrum corresponding to the color of sky. So the third color is your red, orange, yellow. No, yellow does not corresponding to the color of the sky. Let's look at our second one. So let's look at the second option here. So I'll just erase this part so that you do not be confused. Let's look at the second one. So in the second one, this will be by normal, yes or no? So if that is the normal, then we guys very nicely say that your red color will deviate less, right? Red color will deviate less, and it will go like this, right? Very similarly, your violet color will deviate more, right? And it will go like this. Right? So basically you guys can see it will be Vibgyor will be like this, VIBGYOR, right? Where red is your, least deviated color, and violet is the most deviated color, right? So if that is the case, then you guys can see third color from the top, right? So third color, violet, indigo, and blue. Yes, third color from the top is actually blue. Is that a yes or no? So basically option 2 is the correct answer. Option 2 is the correct answer according to a question. Is that a yes or no? I hope you guys can understand that. Yes. Okay, let's move forward to the next question. Okay, this is assertion and reason question. Okay, let's look at this question. Question number 31 to 35 consists of two statements, assertion and reason. Answer these questions selecting the appropriate option given below. Okay, great. So you have 4 options. Both A and R are true, and R is the correct explanation of A. Both A and R are true, and R is not the correct explanation of A. A is true, but R is false, and A is false, but R is true. So you have these 4 options. So in the next question, the 34th question is of physics. So in this, you have this assertion, that is a statement. The statement is saying that sky appears blue in the daytime. Yes, the sky do appear blue in daytime. So the reason for that statement is given that white light is composed of 7 color. Okay, so white light is actually composed of 7 color, but it is not the correct reason for sky appearing blue in the daytime, right? So according to me, assertion is correct, yes, and white light is composed of 7 colors. Both the statement, if I consider them as statements, then both the statements are correct, but reason statement is not the correct reason for the assertion, right? So this will be, so which option will be the correct one? You guys can see both, okay, option number B here, both A and R are true, but R is not the correct explanation of A. So the option number B is the correct answer. I hope that is understandable. Okay, let's move to the next question. This is question number 39. If the power, you guys can see here, if the power of the lens is -4 diopter, then it means that the lens is a, four options are there: concave lens of focal length -50 meter, convex lens of focal length +50 centimeter, concave lens of focal length -25 centimeter, and convex lens of focal length -25 meter. Now, first, one thing you have to be very careful. You know the formula for power is equals to 1 upon focal length, and this focal length is written in meters, right? Yes or no? Okay, so in this question you have to understand the power is negative. Power is negative. If the power is negative, that means power is negative for concave lens. Yes or no? Power is negative for concave lens. Okay, great. So the power is negative for concave lens. So we know that we have a concave lens, right? So we can continue this here. That is, focal length in meter can be written as 1 upon minus of 4 diopter, right? So you just divide in order to get the answer. So answer will be in meter, right? This is -1 upon 4, or you guys can say this is actually 0.25 meter. Is that a yes or no? 0.25 meter, or you can say this is 25 centimeter, -25 centimeter, right? So let's say if there is this answer, so yes, you can say it's a concave lens with focal length -25 centimeters. So option number C is the correct answer, right, for 39. Okay, great. Let's move forward to the next question. Okay, next question is question number 40 of your sample paper. Rays from sun converge at a point 15 centimeter in front of a concave mirror. Okay, great. Where should an object be placed so that size of its image is equal to the size of the object? Okay, so first of all, we are talking about a concave mirror. So let's very quickly make a concave mirror. So this is my concave mirror. All right, great. And okay, so just a minute. So I'll just, so you have this principal axis, great. Now obviously this concave mirror will be having a focus, right, a center of curvature. Yes. Now let's read the question again. Rays from sun converges at a point 15 centimeter in front of a concave mirror. So the rays are coming from the sun. That means the rays are coming from a very far away place. That means the rays will be coming parallel. Yes or no? The rays will be coming parallel because they're coming from a very far away place, right? The rays will be coming from a very far away and the rays will be parallel. Yes or no? Okay, great. Now according to the question, they converge at 15 centimeter. That means the focal length of this lens will be 15. Yes or no? Because we know that your rays converge at the focus. When the parallel rays are coming, when the rays are parallel to the principal axis, they converge at a common point, which we call as the focus of the mirror. Yes or no? I hope that is understandable. Mirror or lens, whatever you call it, right? So for here I have a mirror, so I will simply call it mirror, right? So okay, 15 centimeter is the focal length of this concave mirror. Where should an object be placed so that the size of its image is equal to the size of an object? Now if you remember, if your object is placed at center of curvature, then actually you get a same size image of same but inverted image of your object. Yes or no? So you need to place it at twice the distance of the focal length. So if the focal length is actually 15, then you have to place it at some twice of focal length, that is your 30 centimeter, right? So can we see the option 30? Yes. Here you have more than 30. No, this is not the answer. Between 15 and 30. No, this is not the answer. 15 centimeter in front of a no. 30 centimeter in front of the mirror. Yes. Option number A is the correct answer. I hope you guys can understand that. Yes. Okay, great. Let's move forward with the next question. Okay, this is question number 43 of your sample question paper. If the real image of a candle flame formed by a lens is 3 times the size of the flame and the distance between the lens and the image is 80 centimeter, at what distance should the candle be placed from the lens? Okay, so what distance should be the candle be placed with the lens, right? So basically you are simply asked, you have been simply asked what is the value of u, right? What is the value of u? This is something the question is asking you guys, right? Now what are the things that is given the question? The flame formed by the lens is 3 times the size of the flame. Okay, and distance between the lens and the image. Okay, you are given the value of v, right? The value of v is given to you, and you have given the value of magnification also, right? So magnification is actually 3, right? Now you have to understand whether it be positive 3 or negative 3. So you have to understand that. Okay, let's read that question again. If the real image of a candle, so the image that we are getting is actually real, right? The real image of a candle flame formed by a lens. So we know which lens give us real images. Yes, we're talking about, yes, only we know only the convex lens will give you the real images, right? Only the convex lens will give you the real images. Okay, great. So now I know I'm talking about a convex lens. So if we're talking about convex lens, then we have to understand magnification will be -3. Magnification will be, for real images, magnification is negative. Now that is something which we have studied. Okay, great. So u is something which I have to find out. I know the value of v, right? You know the value of v. V will be positive 80 centimeter, right? V will be positive 80 centimeter. Okay, great. Now I'm supposed to find out the value of u, right? Now how I can find the value of u? Now it is very simple. Let's try to do this. I know the magnification. Magnification is simply given as, for a lens, it is given as v upon u. Is that a yes or no? For magnification, it is given as v upon u. Now the value of m is given to me, that is -3, and the value of v is also given to me, that is 80, and u is something which I do not know. So u can be simply given as 80 upon 3 with a negative sign. So -80 upon 3 should be the answer. Is it there? Yes, it is there. Option number D, -80 upon 3 is the answer, right? I hope you guys can understand. Yes. Okay, let's move to the next question. This is question number 22 of your sample paper. Okay, let's try to solve this. Okay, while looking at the above diagram, Nalini concluded the following. Okay, there's a student named Nalini. Okay, very weird name. I cannot pronounce it properly. Okay, no problem. So you have 4 options. So you have this image. Look at this image. So you have, this is actually, okay, I don't know which image is it, but I'm assuming this is actually a concave mirror. I'm assuming it's a concave mirror, right? The image of the object will be virtual one. No, the image will not be virtual, because obviously the image will be something like this, right? So the image is not virtual, it is very real, right? The image is actually very real, it will not be virtual. So this option is wrong. Okay, second option, the reflected ray will travel along the same path as the incident ray but in opposite direction. Yes, you guys can see, if the ray is going like this, then it will again follow the same path through the center of curvature. Correct, but in the opposite direction. Very correct, the statement is correct. Next one, the image of the object will be inverted. True, because obviously it will be something like this. You guys can see it will be inverted, and from here also the image will be inverted. Okay, this option is also true. This is a concave mirror, and hence the focal length will be negative. Yes, it is actually a concave mirror, like I said. So if it's a concave mirror, then obviously in order to find out the focal, this is the pole. In order to find out the focal length, you have to go in the left direction of your mirror, right, from the pole. So when we are going in the left direction, according to our new sign convention, the value we take to be negative. So your focal length will be negative, right? So this statement is also true. So option number 1 is wrong, but option number 2, 3 and 4 are correct. So which one of the following above statement is correct? So 2, 3 and 4. Yes, this one, option number C. So option number C is the correct answer. I hope that is understandable. Yes. Okay, let's move to the next question. Okay, this is question number 45 of your sample question paper. Okay, so you have this diagram. Look at this diagram. You have medium 1, you have medium 2, you have medium 3, then back to medium 1. Okay, so you have medium 3 mediums, then back to medium 1. Okay, great. So in the above diagram, light is traveling through different media. Yes, I can see the light is traveling from different media. It is noted by scientists that angle 1 is equal to angle 3 is equal to angle 4, but angle 2 is smaller than angle 1. Yes, this is very much evident here, right? So that means angle 1 and angle 3 and angle 4 are same. So what it means, if the angles are same, that means this medium and this medium are of similar nature, right? So medium 1, medium 3 and medium back to 1, so these three mediums are of similar nature, but it is saying that angle 2 is less than angle 1. Yes, you guys can see angle 2 is less than angle 1. Now what it means, it means that this medium is actually denser as compared to this medium, right? That's what it's mean, right? So you can simply write it here. This medium is denser as compared to medium 1, as compared to medium 1. Now this is something which we can conclude from it, right? So let's look at the question. Which of the following statement would be correct? Option number A, medium 1 is denser than medium 3. Wrong. Medium 1 is not denser. Medium 1 and medium 3 are very similar, but density, okay, this option is wrong. Let's move to the second one. Medium 2 is rarest medium. No, medium 2 is not rarest medium. It is actually denser medium as compared to all the other mediums, I guess, right? You guys can understand, you have to understand, medium 2 is actually denser because the light is bending here more. So that means this medium is actually denser, okay? Medium 3 is denser than medium 1. Medium 3 is denser than medium 1. No, if it would have been denser, then the angle should be different. The angle of incidence or angle of reflection should be different. So here you guys can see the angles are same. Angle 1 is actually equal to angle 3. That means both the mediums are of similar nature, right? So that means there is nothing denser rarer here. Both the mediums are similar. So obviously this option is also wrong. Option number D, medium 1 and medium 3 are essentially the same mediums. Yes, correct. Medium 1 and medium 3 are essentially the same medium, but medium 2 is denser than 1 and 3. Yes, correct. Medium 2 is actually denser than 1 and medium 3. Yes, correct. So this option is actually correct. Option number D is actually correct. So you guys can write option number D is the correct option. I hope that is understandable. Yes. Okay, let's move forward. Okay, this is question number 46 of your sample question paper. So the refractive index of flint glass is 1.65 and that of alcohol is 1.36 with respect to air. Okay, great. What is the refractive index of flint glass with respect to alcohol? Okay, great. Now you have to understand, whenever I say that my refractive index of flint glass is with respect to air, then I can simply write refractive index of flint glass divided by refractive index of air, right? So this is how I actually write. So that means refractive index of air is 1 and refractive index of glass is 1.65 and the answer comes out to be 1.65. Very similarly, refractive index of alcohol with respect to air, if you write, it is refractive index of alcohol divided by refractive index of air, and you can write it refractive index of alcohol is 1.36, air is approximately 1, and the answer comes out to be 1.36. Now the question is asking you refractive index of flint glass with respect to alcohol, right? So refractive index of flint glass with respect to alcohol, right? With respect to alcohol. So can I write it like this? Refractive index of flint glass divided by refractive index of alcohol. Is that a yes or no? Now I know the value of refractive index of flint glass, that is 1.65, and I know the value of refractive index of alcohol, that is 1.36, right? All you have to do is divide 165 upon 136, right? It will be something 1 point something. If I divide it, so this will be 1 point, and yeah, it will take 2. Yeah, 1.2 something. 1.2, is it there? Yeah, it's there in the option. Yes, yes, it's there in the option. You guys can see 1.21 is the correct answer. I hope that is understandable. Yes. Okay, let's move forward to the next question. Okay, this is question number 47 of your sample question paper. So you have this diagram is not so clear, but it's okay. Let's try to solve it. The above lens has a focal length of 10 centimeter. So you have to understand this is actually a convex lens. So if it has focal length of a 10 centimeter, that means we're talking about focal length is actually positive, right? So focal length of this focal length is positive, 10 centimeter. Okay, great. The object of height 2 millimeter, so this is the object and its height is 2 millimeter, is placed at the distance of 5 centimeter from the pole, right? So it is being placed at 5 centimeter from the pole. So I know the value of u here, right? But you have to understand we are going in the left hand side, so the value of u will be negative, so I can write it minus 5 centimeter, right? Okay, great. Then find the height of the image. You're supposed to find out the height of the image, right? So what you have to find out, you have to find out height of the image, right? That is something which you have to find out. But you are given height of the object is actually given, right? Now you guys can see height of the object will be positive because we are the height of the object is in the upward direction, so it will be positive, and the height of the object is actually 2 millimeter, right? Remember that in your mind. Okay, so how I can solve this? I'm supposed to find out the height of the image. Okay, the idea is what I will do here is I will simply find out the value of v. So when I find out the value of v, then I can use it for my magnification equation, and from there I can actually find out the value of height of object, height of image upon height of object. So I can do that, right? So let's try first find out the value of v from here, right? Okay, so let me just simply write. So I know by how I can find out the value of v, by lens formula, right? By lens formula I can write 1 upon v minus 1 upon u is equals to 1 upon f. Is that a yes or no? I hope you guys can understand that. So 1 upon v is something which I have to find out, which I do not know. So this is written as 1 upon f plus 1 upon u, right? Okay, let's solve it. 1 upon v is equals to 1 upon f is actually 10. Now u is actually minus 5, so I can write it 1 upon 5, right? So you just solve it for this is 50, this is 5 minus 10. I'm not taking LCM, I'm simply multiplying it. So this will be minus 5 upon 50, or 5, this is 10. So I can simply see 1 upon v is coming out to be minus 1 upon 10, or v is actually equal to minus 10 centimeter. So the value of v is now given to me, right? So now remember, the value of v is given to me, then I can simply use magnification is simply equals to v upon u, and that is also equals to height of your image upon height of your object. Yes or no? I hope you guys can understand that. So magnification is simply equals to, yes, v is minus 10. What is the value of u? U is minus 5, so you can write it here. U is actually minus 5, so this is minus cancel, this is 5 2. So here I can write my magnification is coming out to be 2. If my magnification is coming out to be 2, that means my image is twice the size of your object, right? So if object is 2 millimeter, then your image should be twice, that is 4 millimeter, right? So 4 millimeter, is it there in the option? Yes, correct, 4 millimeter is there in the option. I hope that is understandable. Yes. Okay, let's move forward to the next question. Okay, this is a case study question. So this is a case study question, and this is the last question of your sample paper. Okay, so Noor, a young student, was trying to demonstrate some properties of light in her science project work. Okay, great. She kept X inside the box. So you have this box. Inside this box, she has kept some material. I don't know what material it is, so it is not given in the question as shown in the figure. And with the help of a laser pointer, made light rays pass through the holes. Okay, so these are the rays. So these are the some laser rays she had passed through some holes. So she had made some holes to that box, and she has passed through the holes on one side of the box, and she had a small butter paper screen to see the spots of the light being cast as they emerge. So she has some butter paper somewhere here, right? So from there she can actually see or she can actually spot from where the light is actually coming, right? So first question is, what could be the X that she placed inside the box to make the rays behave as shown? All right, so you guys can see, if you guys carefully see, the ray one should go like this if it is not undeviated, right? So ray one should go like this if it is not undeviated, but actually it is not deviated, it's actually laterally shifted. Can you guys understand this? It is not deviated, it is laterally shifted. So if you guys remember, with the help of a glass slab, we can actually laterally shift the rays, yes or no? So we have studied, let's say I have a glass slab, let's say I have a glass slab like this. So let's say this is your incident, ray, this is your normal, right? And then it will bend because it is glass medium, right? It will bend because of the glass medium, and then again normal, and it will again come back like this, right? So you guys can see here also it is laterally shifted. So basically my guess is that inside this box I have a glass slab. I have a glass slab, right? So let's see the options here. A converging lens, no, a converging lens cannot do that. A parallel side glass block, yes, this can be the option, a parallel sided glass block, right? So your glass slab is actually parallel sided glass block, yes or no? Is that a yes or no? Okay. A plane mirror cannot do that. A triangular prism will not do that. So the answer to this question is actually a parallel sided glass block. I hope you guys can understand. Yes. Okay, next question. She measured the angle of incidence for both the rays on the left side of the box to be 48.6 degree. She knew the refractive index of the material X. Okay, she knew the refractive index of your glass slab. Inside the box was 1.5. Okay, so the refractive index is given to you 1.5. What will be the approximate value of angle of refraction? So obviously light ray is coming like this, and this is how you will make the normal, and because of the normal it will be refracted, something like that, right? So you have to understand, you have to apply Snell's law there, right? So I can simply say, okay, let me just make here, okay, so this is the interface. So your ray one, let's say your ray one is coming. Let's talk about ray one only because both of them will behave similarly. So this is your ray one, and this is your normal, and obviously it will reflect, right? So let's say this angle is given to me, this angle is given, that is 48.6 degree. I'm supposed to find out this angle. R is something which I'm supposed to find out. So how I can find out? I can simply use the Snell's law, right? So here I have air and here I have glass, yes or no? So air has a refractive index of 1, glass it is given 1.5 in the question. So I can say nu1 or nu of air multiplied by sine of angle of incidence will be equal to nu of the material or the glass slab multiplied by sine of angle R. Is that a yes or no? I hope you guys can understand that. Yes, okay. So nu of A is actually 1, right, multiplied by sine of angle 48.6, which is like given to me, is equals to nu of G is actually 1.5 multiplied by sine of angle R. Now this is something which I'm supposed to find out, right? Okay, sine of 48.6 is 0.75, right? It is given to me, so I'll just solve it here. 0.75 divided by 1.5 is actually equal to sine of R. Can you guys see that? Yes. So this is 75 upon 15. Here it is 10, here it is 20, cancel out. This is 75 upon 150. This is 25 3, this is 25 6, or this is 3 1 2, or I can simply say 1 upon 2. So sine R is coming out to be 1 upon 2, and I know R should be 30 degree for it to be half, right? Now I hope this is something which all of you know, right? So the angle should be 30 degree because sine 30 is actually half, right? So the answer is 30 degree. I hope that is understandable. Yes, I hope that is understandable. Okay, great. So I'll just remove all these things, right? Because it is making it look bad. Okay, I hope you guys can understand. I'll just remove all these things. Okay. Okay. All right. So let's do the next question. This is last two questions are left. Okay, let's do. Her friend noted the following observation from this demonstration. Glass is optically rarer than air. No, that is very wrong observation. Glass is optically denser than air, right? So this option is wrong. Air and glass allow light to pass through them when with the same velocity. No. Air and glass have different refractive indexes, and because of that the velocities are also different, right? Air is optically rarer than glass. Correct observation. Third observation is correct, that air is optically rarer than glass. Fourth one, speed of light through denser medium is faster than through rarer medium. Wrong. It is other way around. Speed of light is actually faster in rarer medium as compared to denser mediums, right? So this option is also wrong. Option number 5, the ratio of sine of angle of incidence to the first medium to the ratio of sine of angle of refraction in the second medium gives us the refractive index of second medium with respect to the first one. Correct. This is correct. So option number 3 and option number 5 is the correct options. So let's see which one of the combination of the above statement given below is correct. Okay, option number, yes, you have option number D. So option number 3rd and option number 4th are the correct options, right? I hope that is understandable. Okay, let's move to the last question. This is question number 60, again part of your case study. If the object inside the box was made of a material with a refractive index less than 1.5, then lateral shift of the rays would have been less, lateral shift of the rays would have been more, lateral shift of the rays would remain the same as before. There is not enough information to comment on any of the above statement. Okay, so what we are saying that we have a glass slab. Now let's try to actually draw and try to understand this question, right? Let's draw it and try to understand. So you have the glass slab, right? So you have this glass slab, you have this glass slab. Okay, so I have this glass slab. So let's say you have incident ray, right? And this is the normal, right? So if the refractive, now let's say right now the refractive index of the glass is actually 1.5, right? It is actually 1.5, and for that 1.5 it has bended some angle, and we are getting something like this, right? So basically you guys can see, if so I have this lateral shift here, right? Okay, great. Now imagine this time my mu is actually less. My mu is some 1.3. My refractive index is less. If my refractive index is less, then I know that my bending is actually going to be less. Yes or no? If my refractive index is less, then my bending will be less. Is that a yes or no? So that means this time my refractive index is less, then my bending will be less. So if my bending is less, then you guys can see something like this happen, and okay, and it will go like this. So can you guys see the shift is actually been reduced? Can you guys see? The shift is actually being reduced as compared to the first case. Is that a yes or no? The shift, or I can say the shift is actually reduced. I hope you guys can understand that, right? The shift is actually being reduced when I have reduced the value of the refractive index of the material or the glass. Yes, if I further reduce, right, it will actually come on its own way. It will not refract at all. Yes or no? So basically, let's see the options once again. The option is lateral shift of the rays would have been less. Okay, option A is actually right away correct. Option B is lateral shift of the rays would have been more. No, this is wrong. Lateral shift of the rays would remain the same as before. No, wrong. There is not enough information. This is also wrong. So option A is the correct answer. Okay, so I hope you understood this particular video. I hope you understood all of the answers. If you have any doubt, you can comment it down in the comment section. And that's all for today. Thank you and have a nice day.